All right, everyone. Assalamu alaikum. Let's begin. So, in the last session, we covered a number of concepts on coordinate geometry. There are just a couple of things that are left in this topic now, apart from equation of circle. Let me quickly remind you what we did in the last session, and then today we are going to start with some questions from the worksheet first, and then hopefully we will have enough time at the end to cover the remaining remaining concepts that we want to do. Apart from equation of circles. So I would want to complete the concepts today, and then if you have more problems, we can discuss them tomorrow. And then we would want to start differentiation this week as well, inshallah, after this. Okay, so what topics do we have left now? Differentiation, integration, functions, including function transformations and APGP. So we still have 4 topics to go, which functions is a big one. An equation of circle, of course, that as well. So you can expect some extra classes this month as well, by the way. So keep that in mind. We will also need to change our timings for Ramadan from next week. I'll be leaving a poll. I'll be posting a poll on the WhatsApp group for that. And so there are basically 2 options. We could either have them in the afternoon. I will be able to tell you the exact times. We could either have them in afternoon on Fridays, Saturdays, and one other day, the regular classes, and then maybe an extra day as well. We will have to decide that as well. So that's one possibility. In the afternoon, sometime between 2:30 and 4:30, I guess. Or the other possibility is that we do it at night, which is going to be the same day as Monday, Wednesday, Thursday, perhaps from 10 to 12. So some between 10 and 12. So sometime around that. So I'll be posting a poll on that. And then based on what most of you prefer, I'll be deciding which one of the 2 time slots we use. We choose to go with. But I want to first hear, in case any of these times clashes with the Maghrib time for you, 10 to 12. So I'm sure 2:30 to 4:30 would not be Maghrib time for anyone, because we are behind most of the other countries that you come from. And so Middle East is ahead of us. Bangladesh is ahead of us. I think is Bangladesh ahead of us? Let me just check the time in Bangladesh right now. Just give me a minute. Okay, so it's currently, yeah, okay. So that should also be fine. Yeah, so for 2:30 to 4:30 Pakistan time should not be a problem. At least it does not clash with Maghrib for any one of you. And not it doesn't clash with Taraweeh as well, I think. 10 to 12 might clash with Taraweeh for some of you, so you can let me know in the poll. We can see which one of you prefer, which one of the 2 options most of you prefer. We'll have to just go with that then. 10 to 12 as well. Can someone please confirm if that clashes with Maghrib for anyone? 10 p.m. to 12 a.m., 12 midnight, Pakistan time. That's not Maghrib time for anyone, right? Okay, so I'm assuming that's
No,
not.
sir. No, sir, it
Okay.
doesn't clash with Maghrib.
Okay, all right. So again, we'll go with the majority, what most of you prefer then. All right. Now, let me quickly remind you about what we did in the last session. We talked about how to find gradient of a line from its equation, right? By converting into y equals mx plus c form. Before that, we learned how to solve simultaneous equations and what simultaneous equations mean graphically, as in solving the means graphically. It gives us the point of intersection of those two lines. Then we talked about properties of these diagonals, right? For all of these different quadrilaterals, we need to know about the properties of the diagonals, whether they're equal, or whether they meet at midpoints, or whether they are perpendicular. In square and rhombus in particular, you need to remember that the diagonals are perpendicular bisectors of each other. Okay. And you need to remember the other properties as well, especially the ones that are highlighted. And then we did this vector method to find coordinates of a point. We did a number of examples in this as well. And then finally, towards the end of our last class, we talked about how to find equation of a perpendicular bisector, right? And that's what we did in the last session as well. And using these concepts, you should have been able to do almost all questions from the worksheet already, because the two concepts that we're left with, they're not tested as frequently. So in the worksheet questions, they were probably not really required much. So you should have been able to do most of the worksheet already. Now, first of all, can I hear from you how many of you are done with at least 5 questions from the worksheet? Can I have raise of hands? How many of you are done with at least 5 questions from the worksheet? Arham, Aisha, Hera, Naima, are you guys a bit behind? Okay. Arham, Aisha, Hera, what about you? Okay, so most of you have attempted questions then. Now, you can let me know if you have any specific questions from the worksheet. We can discuss them. Naima, I've seen your message. Okay, that's great, Arham. You're done with 10. Naimas, we're asking about question number 5 of the trigonometry worksheet. We will do that towards the end then, okay? So let's start with the coordinate geometry concepts then. And then towards the end, we can discuss that question as well. Let me just have a look at that quickly. If I can maybe give you a hint and you can figure that out then. Or if it's going to need more time, we will do that at the end then. Okay, so we'll do it at the end, okay? We'll do it at the end. Okay, first of all, let me know from the coordinate geometry worksheet if you have any particular problems. It was a fairly easy worksheet, I think. Most of the concepts are just O-level concepts. So I hope you did not have much problems. But if you did, please do let me know so we can discuss them. Okay, question number 14 and 19. Let's start with these questions then. Okay, so let's start with this one. Question number 14 from the worksheet. Let's have a look at this. Okay, so it says in the diagram, A is the point -1, 3, and B is the point 3, 1. The line L1 passes through A and is parallel to OB. Okay, so the line L1 passes through A and is parallel to OB. Okay, so if we were to draw a line from O to B like this, AC is parallel to that. Okay, so AC is parallel to that, parallel to this line. Okay. The line L2 passes through B and is perpendicular to AB. L2 is, yeah, so that's given here as well. This is the 90 degrees angle. You can see that here. This angle is 90 degrees. The lines L1 and L2, they meet at C. This is the point where these two lines meet each other. We need to find the coordinates of the point C. Okay, now Point C is the point of intersection of lines L1 and L2, right? So think of it from the bigger perspective, first of all, as in, what do you want at the end? You want the coordinates of the point C. How are you going to get to those coordinates? If you had the equations of the line L1 and L2, you can just solve them simultaneously and find the point C. Okay. So the first problem then is how to find the equations of the lines L1 and L2. Let's start with L1 first of all, let's say. What about L1? In order to find the equation of a line, we need two things. We need a point that lies on the line and the gradient of the line. Now we have a point that's -1, 3. This point lies on the line. So we have a point that's -1 and 3. We also need the gradient of this line. Now for that, we're given that the line L1 is parallel to OB. Now parallel lines have same gradients. We can find the gradient of the line OB. That will be the same as the gradient of L1. Okay. So what is the gradient of L1? That is going to be the same as the gradient of the line OB. Okay. Now what's the gradient of OB? It passes through origin and the other point is 3, 1. We can't find the gradient of L1 directly because we only have one point. But we can find the gradient of OB because one point is origin. That means 0, 0, and the other point is 3, 1. We can just apply the gradient formula here. 1 minus 0, y2 minus y1 over x2 minus x1. That's 3 minus 0. The gradient turns out to be 1 over 3. And that's the gradient of the line L1 then. We can write down the equation now. The equation turns out to be y minus y1 equals m into x minus x1. Let's just input points here. This is x1, y1, and this is m, 1 over 3. So what's the equation going to be? Y minus 3 equals 1 over 3 into x plus 1. That's the equation. Okay. That's the equation of line L1. Now, since we need to solve this simultaneously with the other equation, it's going to be helpful if we simplify this. If I simplify this and make y the subject, that's going to give me 1 over 3x plus 1 over 3 plus 3. And that turns out to be 1 over 3x plus 10 over 3. That is one equation. Now we think of the equation of the line L2. How can you find that now? L2 is perpendicular to AB. Now again, L2, the gradient of L2 cannot be found directly. We don't have 2 points on the line L2. We only have 1 point, which is 3, 1. Okay, so on L2, we have 1 point. That's 3, 1. Let me just write that here first. There's 1 point that lies on this line, 3, 1. And this line is perpendicular to AB. What we can do is we can find the gradient of AB and then, we can find the gradient of AB, and that's just take reciprocal of that, negative reciprocal of that to find the gradient of L2 then. Okay, so let's find the gradient of AB. What's that going to be? M of AB. Y2 minus y1 or x2 minus x1, I can do 1 minus 3 divided by 3 minus minus 1, that becomes 3 plus 1. And that gives us minus 2 over 4, which is minus 1 over 2. That's the gradient of AB. If the gradient of AB is minus 1 over 2, then what about the gradient of L2? It's going to be negative reciprocal of this. Change the sign, take reciprocal, that gives you 2. Okay, now I can write down the equation of this line as well. That's y minus y1 equals m into x minus x1. That gives us y minus 1 equals 2 into x minus 3. And that's the equation of the second line. This can be simplified to y equals 2x minus 6 plus 1. That's going to be minus 5. This is the second line. We can just solve these two equations simultaneously now. And that is going to give us the coordinates of the point C. What's the first equation? The first equation is y equals 1 over 3x plus 10 over 3. And the second equation is y equals 2x minus 5, we can use substitution or just equate these two lines because we have y the subject in both of them. We can say 1 over 3x plus 10 over 3 therefore should equal 2x minus 5. Now, in order to get rid of this fraction 3 in the denominator, we can just multiply the whole equation by 3. If we do that, we're left with x plus 10 equal to 6x minus 15. And that gives us 5x equal to 25. The value of x turns out to be 5. Put that back in any one of those two equations. Y equals 2 into 5 minus 5. And that also turns out to be 5. X and y coordinates both 5. So we can say that that point C is 5 and 5. And that is what we were looking for. The coordinates of point C therefore are 5 and 5. Okay. Now it's a good practice generally in such questions that once you have found the answer, just do a sanity check that is it possible? Is it possible for this point C to be 5, 5 on the diagram? Because sometimes you end up doing a careless error, and just doing this quick check can help you identify that error, because you can see if this is 5, 5, and think of the other points given on the diagram already, this is 3, 1. Okay, so this is 3. So it makes sense for this point to be 5. So that looks okay. And if this is 1, it also makes sense for this point to be 5. That also makes sense. Okay. So on the diagram, it looks reasonably accurate. If one of these was, for example, if the x coordinate was 10, now that should make you realize you've done something wrong, because if this is 3, then it's very unlikely for this to be 10. Okay. So just have a look at the diagram and see, okay, the answer that you're getting, is that likely to be correct? Now, of course, the diagram is not exactly to scale, but still it's approximately the same as what the actual diagram should look like. So have a look at the diagram to see if the answer that you're getting would make sense or not. Okay, so that's the final result that we're getting. 5, 5 are the coordinates. Make sense? Any problem with this?
No, sir.
Okay, let's have a look at another one then, which was question number 19. So the rest of you as well, if you have any questions, let me know in the chat box so we can discuss those as well. So the next that Anna is asking about is question number 19. Sorry. Okay, let's try this. Question number 19 from the worksheet. Okay, so it says the line x over a plus y over b equals 1, where a and b are positive constants, meets the x-axis at p and the y-axis at q. Given that PQ equals square root of 45, that means the distance of P from Q, that's square root of 45, and that the gradient of the line PQ is minus 1 over 2. Find the values of A and B. So we have two pieces of information given. The distance between the points P and Q and the gradient of the line PQ. And we can use them to find the values of A and B. Let's see how we can do this. Now it says A and B are positive constants, and the line meets the x-axis at P. That means P is the x-intercept, right? And Q is the y-intercept. Okay, that's what we're given. Let's find the coordinates of P and Q first of all. In terms of A and B, of course, the equation is x over A plus y over B equal to 1. How do you find the x-intercept? For finding the x-intercept, you put y equal to 0. So that's what we do first. Let's put y equal to 0. If you put y equal to 0, that gives us x over a plus 0 over b equal to 1. That means x over a equals 1 and x equals a. So this point P that we are looking for, the x coordinate of that is going to be a. What about the y coordinate? The y coordinate is 0 because that's the x-intercept. The y coordinate is 0 at the x-intercept where the graph cuts the x-axis. So this is 0. That's the point P that we were looking for. Similarly, for finding the y-intercept, you put x equal to 0. If you put x equal to 0, what do you get from that? 0 over a plus y over b, that equals 1. Now that gives you y over b equal to 1 and y turns out to be equal to b. That means the coordinates of q therefore are, the coordinates of q are 0 and b, because the x coordinate is 0, y coordinate is b. So we have the coordinates of p and q in terms of a and b. Now we can just use the distance formula and the gradient formula. So distance pq, the question says that is supposed to be equal to square root of 45. And the gradient of pq, that is supposed to be minus 1 over 2. So we can find our own distance from the points that we have and our own gradient, and just make two equations from that. So what's the distance pq? Remember the formula? x2 minus x1 whole squared plus y2 minus y1 whole squared. That's what we have to do. Let's call any of them x1, y1. Let's call this x1, y1. Let's call this x2, y2. Okay, so x2 minus x1, that's 0 minus a whole squared plus y2 minus y1, that's b minus 0 whole squared. Square root of that equals square root of 45. Now, first of all, we can get rid of the square roots. If you square both sides, the square roots get removed. What are we left with? A squared plus b squared, that equals 45. That's one equation that we have. Let's look at the other one. Gradient of PQ, that means y2 minus y1, which is b minus 0 over x2 minus x1. That's 0 minus a. This should equal minus 1 over 2. And that leaves us with b over minus a. That is equal to minus 1 over 2. We can cross multiply. The minus sign also gets removed, right? Because we have negative on both sides. So we're going to be left with 2b equal to a. This is another equation that we have. We can solve these two simultaneously now. We have a equal to 2b. Let's put that in the first equation. If we put that here, that gives us 2b whole squared plus b squared equal to 45. So we are just inputting a equal to 2b. Okay. That leaves us with 4b squared plus b squared equals 45. Make sure to put 2b inside bracket like this, 2b whole squared. Okay. That gives you 4b squared plus b squared. That is 5b squared equal to 45. And then b squared equals 9. You take square root. When you take square root, you have plus minus 3. However, if you remember, the question said a and b are supposed to be positive constants. That means you're only going to consider the positive value. So that means b is supposed to be equal to 3. Put that in the other equation. That gives you a equal to 2 into 3, which means a equals 6. And that is what you were looking for. A equals 6 and b equals 3. Is that all right?
Sir,
Yes.
sir, why did you put PQ equals under root 45?
Because the question says that.
Yes, sir, because distance is already given, so why are you finding distance again for PQ?
If you're not finding distance again, we have to find the values of a and b, right? So in order to find a and b, we are using the information given in the question. We're using this distance. We're saying the distance between p and q should be equal to square root of 45. Now, if we know the coordinates of p are this and the coordinates of q are this, We are using that information given in the question to make an equation between A and B that we can use to find the values of A and B. That's the whole point of having that value given in the question. They've given us this value so that we can use it to find A and B. So we're making an equation using that given information to find A and B. We're making an equation here using that distance value, making another equation using the gradient, and solving them simultaneously to find A and B.
Okay, sir.
Right? Any other problems? Any other questions? No? Okay, so if there are no questions, let's look at our next concept then. Finding area of a shape using its coordinates. Okay, Aima, that delayed question makes me think that you're just looking at the questions and seeing, okay, this question looks difficult, so we should perhaps try this. But let's do it now.
Sir, I thought you were asking that if you understand the question or not, that you were.
Okay, so have you tried this first before?
Yes, sir, but I didn't know how to find the area of triangle.
Okay, all right. Let's start. Let's do it first, and then we discuss this next concept. Question number 36. Let's have a look at this. Yeah, 36. Okay. It says the line with gradient -2 passing through the point P intersects the x-axis at A and the y-axis at B. We need to find the area of the triangle AOB in terms of T. Okay. That's actually kind of related to what we wanted to discuss just now as well. Gradient is -2. The point P is here. It intersects the x-axis at A and the y-axis at A. Okay, so we can actually do it without covering that concept. Let's do it, and then we'll discuss a general method to find the area of a shape using coordinates. But let's do it first. Let's do this first. We have a line that has gradient -2, and it passes through the point P, 3t and 2t. This line intersects the x-axis at A and the y-axis at B. We need to find the area of the triangle AOB, where O is going to be the origin, right? O is the origin. Now, how can you find this area? We first need to find the values of, first define the coordinates of A and B. Let's find those coordinates. So we have a line that has gradient -2, and the point that the line passes through is 3t and 2t. Can we write down the equation of this line? We have a gradient and a point. Y minus y1 equals m into x minus x1. We can write down the equation of this line. Why do we need to do that? Because we want to find the x-intercept and y-intercept of that line. Now, in order to be able to find the x-intercept and the y-intercept, we need the equation of the line first. So we're looking for the equation of the line first. And then once we have that, we can find the x-intercept and the y-intercept using that. Let's write down the equation. So we have y minus 2t, right? We're saying this is x1, this is y1. So y minus 2t, that equals m, which is minus 2 into x minus 3 times t. Let's simplify this. This gives us minus 2x plus 6t plus 2t, and y equals minus 2x plus 8t. Now, how do you find the x-intercept and the y-intercept of this line? You put x equal to 0 to find the y-intercept and y equal to 0 to find the x-intercept. Okay, so if we input x equal to 0, that gives us y equals 0 plus 8t, which is just 8t. That means 1 point is 0, 8t. This is the y-intercept, okay? Y-intercept was b. So these are the coordinates of the point b. We put y equal to 0 to find the x-intercept. Once we input y equal to 0, that gives us 0 equals minus 2x plus 8t, and 2x equals 8t, x equals 4 times t. All right. Now, when you put y equal to 0, we get the x-intercept. So this point is a, right? It says the x-intercept is a. The coordinates of a are 4, t, and 0. Now, think about it. It's a line that has negative gradient. Gradient is -2. What is the line going to look like? It's going to be something like this, right? The y-intercept is 8t. Now, it actually depends on whether the y-intercept is positive or negative. It depends on the value of t. The line could look like this. This is one possibility. Or it could look like this. It could look like this. Both are okay. So in this case, you get this equation, this triangle. And in the earlier case, you get this triangle. It could be any of the two cases. It doesn't make any difference for us. We're going to find the area in terms of t. Let's say it looks like this. A is the x-intercept. That means this is the point A. It has coordinates 4t and 0. That means this is 4t. Y-intercept is B. This point is 8 times t. How can you find the area of this triangle? Half into base into height. It's a right angle triangle, right? So you can just say area equals half into base. Base is 4t. This is the triangle AOB, right? Base is 4t. And height is 8t. And that gives us 16t squared. That should be the area of this triangle. Okay. Now in coordinate geometry, especially when we do equation of circle later, you'll find that sketching the diagram is going to be very helpful sometimes. So in this case, when you sketch this, that this is how the situation is going to be graphically, then you can figure out, okay, it's a right angle triangle, and you can just find the area of the right angle triangle using half into base into height. Okay. So that's the area of this triangle. That's the first part. Now, the second part says the line through P perpendicular to AB intersects the x-axis at C. Show that the midpoint of PC lies on the line y equal to x. Okay, now it says show that the midpoint of PC lies on the line y equal to x. Now, in order to show this, you just have to find that midpoint and show that the x and y coordinates of that point are the same. So essentially, all you have to do is find the midpoint of P. That's the main thing that you have to do. You have to find the midpoint of PC. That's what the actual problem is. Okay, but then if the x and y coordinates turn out to be the same, it means that it lies on the line y equals x because it would satisfy this equation. Now, how do you find the midpoint of PC? P is a point that's already given, in fact, here. That's 3t and 2t. So there's some point 3t and 2t here. It's going to be maybe here. 3t and 2t. 3 and 2. Okay, let me just check. This is going to be okay. So it's either going to be, so we can actually figure out whether it's going to lie on the line. In fact, is it going to lie on the line? We have the equation of the line. X is 3t and y is 2t. Yeah, so this point actually lies on the line. And yeah, it tells us that. I'm sorry. So the question says the point P lies on the line. So the point P is going to lie on this line. It's going to be here. Let's say this is point P. Okay, this is point P. Now it says the line through P perpendicular to AB. So there's a line that passes through the point P, and that line is perpendicular to AB. How is that line going to look like? Like this. It passes through a point C on the x-axis. Okay, this is the point C on the x-axis. Show that the midpoint of PC lies on the line y equals x. How do you find the midpoint of PC? That's the question. Okay. Now, in order to find the midpoint of PC, we first need to find the point C. We already have the point P that has coordinates 3t and 2t. If we can find the point C, we can find the midpoint of PC as well. How do you find the point C? C is the x-intercept of the line PC. If we can find the equation of the line PC, we can find the x-intercept of that line. How do you find the equation of PC? We already have a point that lies on this line. We have 3t and 2t. This is the point that lies on this line, right? And this line is perpendicular to AB. So whatever was the gradient of AB, the gradient of PC is going to be negative reciprocal of that. So what was the gradient of AB? Gradient of AB was -2. It was given in the question. The gradient of PC would be negative reciprocal of that. That means change the sign, take reciprocal, it's going to be 1/2. And now we can write down the equation of PC. Y minus y1 equals m into x minus x1. What do we get from this? Y minus 2t, that equals 1/2 into x minus 3t. Okay, so what you want to find is the x-intercept. Now let's just put y equal to 0 directly. Let's find the x-intercept. Put y equal to 0 to find the point C, right? Because that's the x-intercept. We put y equal to 0. When we put y equal to 0, we get 0 minus 2 times t. That equals 1/2 x minus 3t. Let's multiply this 2 on the other side. This is a 2 is in the denominator of this whole thing. So we can just take that to the other side and make it minus 4t. That equals x minus 3t. And x turns out to be minus t from this. Okay, x turns out to be minus t from this. Now that means this point that we have represented here, our diagram is basically inaccurate. The point C would have been on this side. If the line was here, the point C would have been on the left side, but that's okay. We just draw the diagram to understand how the situation is going to be. It does not have to be very accurate. It's not going to be checked. It's just to understand, okay, this is how the situation looks like roughly. We have found the x-intercept, that's negative t, and that's okay. That means the coordinates of point C therefore are minus t and 0. So we have the point C now, and we have the point P already given. Okay, now you can find the midpoint of PC and see what that turns out to be. Midpoint of PC. How do you find the midpoint? x1 plus x2 over 2, 3t minus t over 2. So that's 3t minus t over 2. And then you do y1 plus y2 over 2, 2t plus 0 over 2. And that gives us t and T as the midpoint. So the midpoint of PC is TT. Okay. Now, how do you prove that this point lies on the line y equals x? Well, you can just put that point there if you want. You can just write a statement that the coordinates are equal. So that's obvious that it lies on y equals x. Or if you want to do it explicitly, you would say, okay, y equals x. Just put those points, t equals t. It satisfies. So this point lies on y equals x. Because if this point was to lie on this line, it should satisfy the equation. It does satisfy when you input that in the equation, t equals t. So it does lie on the y equals x line. That's what you would do in this problem. Any questions on this? Any questions, anyone? Does this make sense? Amma, is that okay?
Yes, sir.
Okay, any other questions? Anyone? No? Okay, so if there are no other questions, let's quickly discuss one more concept before we end today. So there's going to be one concept left for the next class, and that is angle between two lines. And the next class is also going to be the last class that we spend on this. We will do some remaining questions that you have from the worksheet, and hopefully we can wrap it up with that. Yeah, so I wanted to do this concept. Finding area of a shape using its coordinates. Okay, now, just like in this question that we just did, sometimes in coordinate geometry, what happens is you have some points, and those points, when joined, make some kind of a shape. It could be a triangle, it could be some other quadrilateral, and you have to find the area of that shape, okay, using the coordinates. Now, that's what you want to learn here. Mostly, it's going to be a triangle. So let's start with a triangle first. How would we find areas of triangles given the coordinates? Let's start with an example. Let's say we want to find the area of a triangle, the area of triangle ABC, such that the coordinates are 2, 5, and you have 2, -3, and -4, and 2. We want to find the area of this triangle, ABC. Okay, I'll give you a minute first to think about this, and let me know if you can figure out this area yourself. It's not going to necessarily require any new concept as such. It's just a way to approach this that I want to discuss with you. But since it's pretty straightforward, you should be able to figure it out yourself as well. So maybe you can try it once yourself, and then we will discuss how we can do it maybe more efficiently. So take 30 seconds, take a minute, and do this. Let me know the area that you get in the chat box. So it's a triangle ABC. It's a triangle ABC. We have the coordinates of the triangle given. We want to find the area of the triangle. We have the coordinates of the vertices of the triangle. Yes. Do I have any result for this? Any answer for this? What should the area be? Okay, I'll give you a hint. Try sketching this. Try sketching this, and that might help you think of this better. Sketching would help. -9, well, area cannot be negative, so you mean 9 basically, right? Saying area is 9. Okay. Let's give others a chance as well. So what about the rest of you? Hazim, that's correct. That's good. Okay, so I have one correct answer yet. I'm not telling you what that is, so you can try as well. What should the area be? Let me sketch it as well. So if you were to sketch this, you have X and Y axes here like this. This is Y, this is X. You have origin here in the middle. 1 point is 2 and 5. That means it's going to be on the left side and above somewhere. Let's say that it is somewhere here. Now, you don't have to make it very accurate, as in, sorry, 2 and 5, I'm sorry, it should be on the right side. 2 and 5 is, let's say, somewhere here. Let's say this is 5 and maybe this is 2. So this is 2 and 5. And we have 2 and -3. That might be somewhere here, let's say. Let me actually just make it slightly more accurate. Let's take this point slightly above. Let's call this 5. And then this would be -3. And then we have -4 and 2. -4 might be somewhere here. Then -2, that's, sorry, what am I doing? This is +2. It should be here. Okay, let's draw this triangle. These are the 3 points. A, B, and B and C. This is what the triangle looks like. A, B, and C. Yes, Naima, that's correct. So I have 2 correct answers yet. Now it should be pretty straightforward. Looking at this diagram, what do you think? What should the area be? Remember the area of triangle formula that you know of? We've done that, done this before as well in trigonometry. Area of triangle is given by half into base into height. That's one formula, and the other formula was half into AB sine C. These are the 2 triangle formulas that we've done. Okay. Now, half into base into height can only be used when you have one side and perpendicular height based on that side. So if we use this as the base, for instance, so base can be any of the sides of the triangle. It could be this side. If we use this as the base, the perpendicular to B would look like this, right? Now base, the length of base can be found, but finding that perpendicular is going to be different because we can't assume that it's the midpoint. It could be any point, so it's going to be a bit difficult to find that. If we assume this to be the base, in that case as well, we have the same problem. Perpendicular is going to look like this. This is a 90 degrees angle. And again, finding the height is going to be a problem. However, if we take this as the base, remember base has to be a side of the triangle always. The base has to be one of the sides of the triangle. This, if we take this as the base, then what would the height be? Height would be perpendicular to the base, coming from the third point. This is going to be the height. And just by looking at the figure now, you can figure out what the length of the base is. You're going from -3 to 5. What should the length be? -3 to 5. 5 minus -3, that's 5 plus 3. That gives you 8. So the length of the base is 8. And now since height is also horizontal, you can find this height as well. You're going from -4 to +2. -4 to 2, what's the length? The length is 6. So height is 6. You can find the area now quite easily using this area formula. Half into base into height, you can see that's half into 8 into 6, and that gives you 24. That's the area of this triangle that we were looking for. Okay. So the idea in such problems is when you have to find the area of a triangle like this, if you have a side that is either horizontal or vertical, you take that as the base. Okay, whatever side is horizontal or vertical, you take that as the base. Okay, let me write that down. So one thing that's going to help you here is whatever side for a triangle, if you have a side that is either horizontal or vertical, you take that as the base. How would that help? Because if it's vertical, height would be horizontal. If the base is horizontal, height would be vertical. And then on these XY axis, you can just count the number of units that you have to go. You don't have to apply any distance formula, find any angles, or do anything like that. You just count, okay, you're going from -4 to 2 here, that's 6 units. You're going from -3 to 5 here, that's 8 units. You would not need to do any complicated calculations for this. So in this case, AB was vertical. So you say, just take that as the base. And then perpendicular would be just a line that's coming from the third vertex that's perpendicular to AB, that's height, and you can calculate that length quite easily as well. Okay, now let me write down another example. Let's say you had to find the area of a triangle, of another triangle that had these coordinates now. Okay, so we have another triangle now, triangle PQR, and their coordinates are, let's say the coordinates are 2, 5, and then we have -3, 5, and 6, 11. Find the area of triangle PQR such that their coordinates are given by this. What about this now? How do you find these? How do you find the area of this triangle? Any idea? Now in the previous example, you see, we had 2 points with the same x coordinates. We had 2 points with the same x coordinates, A and B. That meant that A and B have the same x coordinate, that means this line is going to be vertical. Do you have any coordinates here in this second example? Sorry. Do you have any coordinates here in this example that are the same for any of the 2 points? X coordinates are all different. Y coordinates for P and Q, if you notice, they are the same. Now, since these Y coordinates are the same, that means P and Q are going to be at the same level. So again, if you were to draw this like this, you have y-axis here and you have x-axis here. And if you were to plot these points, P would be 2 and 5. Let me say this is 0. This is, want to go up to 11. Let's say this is 10, 2, 4, 6, 8. On the right and left, we want to go up to 6. Let's say this is 6. Then this would be half of that. We have 1, 2, 3, 4, 5, 6 like this. On the negative side, we want to go up to 3. So this is negative 3, and that's it. Okay. Let's plot these points. Again, it does not have to be very accurate. You just do a rough sketch to try to understand what it looks like. 2 and 5. 2 and 5, that point is going to be here. That's one point. This is point P. Minus 3 and 5 is going to be here. And then 6 and 11, that is going to be here. So this is what the triangle looks like. This is what the triangle looks like. Okay. Now, again, we said these 2 points have the same y coordinates, P and Q. So this is P, this is Q, and this is R. So P and Q are at the same level. So this line is horizontal. We said whichever side is horizontal or vertical, we are going to take that as the base. Okay, because taking another side as base would not be helpful. If we take this as the base and perpendicular to this, it's going to be hard to find that. If we take this as the base, then the perpendicular is going to be outside the triangle. In fact, it's going to be like this. This, again, that's hard to find. If we take, however, PQ as the base, if we take PQ as the base, we can find the length of PQ directly. That's pretty straightforward to find, right? We're going from minus 3 to 2. That's 5 units. So we take this as the base. That's 5 units. Now, height is going to be the point, the line coming from the third vertex that is perpendicular to the base. Now, this is going to be outside the triangle in this case. We would have to extend this line like this. You would say, outside the triangle, this is what the base is, right? Height is going to be this length here. This is the height. Because height is always perpendicular to the base, right? So this is the height. What's the length of this height now? We're going from 5 to 11. This point is 5 and this point is 11. You have to go from 5 to 11. That's 6 units. So the height is 6. And now we have the base and the height. We can find the area of the triangle. The area of the triangle therefore becomes half into 5 into 6, and that gives us 15 units square. That's the area of the triangle. So in most questions, the triangle that you get, it is going to have one side either horizontal or vertical. And in that case, you would take that side as the base. Okay, that's what you have in almost all questions that you get in Cambridge. You have one side either horizontal or vertical, and that makes this calculation pretty straightforward like this. Okay. Neema, do you understand this? I'm not sure how you can get that number, because you see, so again, when you're doing these calculations, make sure to do a quick check like this as well, that does this number look possible? So you're saying the area could be 123. Okay. Now, can the area be that big? Because if you think this is 11, and this length from -3 to 6, that is 9. Even if you were to find the area of this whole rectangle, that would be 11 into 9, 99. The area of this big rectangle even is going to be 99. So the area of that triangle cannot be that big, 123. All right, it has to be much smaller than that. So whenever you do such calculation, always think about this. Does this look possible? Because in this case, getting such a large area is not going to make sense. Okay, yeah, all right. So the base is 5, height is 6, and we get 15 as the area of the triangle in this case. Any problem with this? Any questions, anyone?
Sir, if we were given the angle, OPR, could we find the area of the triangle with the sine equation? Could we just use OP?
Just a minute. OPR, that means this angle?
No, I meant the other O, the other point.
QPR. You mean this
Q,
angle?
okay, yeah.
Yes, you could use half into AB sine C in that case. If you found the length of PQ, that's 5. You could find the length of PR as well using the distance formula. And then you could use half into AB sine C. That will work. Yes, you can do that.
Okay, thank you, sir.
Okay. All right. Now, this is what you're going to have in most cases, that you would have one side that is either horizontal or vertical like this. Now, it is possible, although very improbable, that you would get something that does not have any side that's either horizontal or vertical. So let's say I had some random points here like this. Let's say there's one point P, which is 2 and 3. There's another point which is -2 and 5, and there's another point which is -3 and 4, let's say. Okay, what is this equation going to look like now? What is this triangle going to look like now? This triangle is going to look like this. If we were to draw this here, this is the y-axis, this is the x-axis. P, Q, and R. Let's plot these points. This is going to be origin in the middle. Then -2 and 5. Let's say that point is somewhere here. I'm just going to draw mark them quickly now. This is Q. Then P is 2 and 3, a bit on the right, and then maybe here. This is P, and then R is -3, maybe somewhere here, and then 4 here. This is going to be R. Now this is what this triangle looks like. Okay. PQR, this triangle that I've drawn, that we have the coordinates for. And this is what the triangle looks like. Now, this is not that straightforward, because now we don't have any side that is horizontal or vertical. So using that same idea that we were using before is not possible in this case. Okay. Now, for such problems, one idea is that we find one of these angles, right? That is possible. You could try finding one of these angles. How would you do that? One possibility is using the gradients, but in fact, let me do it the other way. One possibility could be that you find these lengths. Let's call these lengths A, B, and C. Can you find these lengths using distance formulas, right? You can find the length PQ, QR, and PR. Using distance formula, you can find all of these lengths. Once you have 3 lengths of a triangle, you can use cosine rule to find an angle. Remember that rule? A square equals B square plus C square minus 2BC cos of A. You could find any one angle. And then once you have that angle, you could use half AB sine C to find the area of the triangle. That's one possibility. But that's quite long. You use distance formula 3 times to find all the 3 lengths. then use cosine rule to find an angle, and then you use that area formula to find the area. That is possible, that can be done. But we have another method, and that is something that we call shoelace formula. Let me write that down. Shoelace formula. Now we call it this because that's how the formula looks like when we write it down. It looks like shoelaces. Let me show you why. So area of a triangle could be given by this. We write this formula like this. This is the way to remember this. This is not the actual formula, what I'm going to write first, but then I'll write the actual formula after that, using what I'm writing here first. So just give me a minute. So what you do is you write the coordinates of the vertices like this. You say the first point is x1, y1. Let me just copy them here. And these are the 3 points. What I'm going to do is I'm going to call this x1, y1, this x2, y2, and then this x3, y3. It could be in any order. It does not really matter in a triangle. You can just use any order. So you have x1, y1, and you write x2, y2, and then you write x3, y3. And then at the end, you again write x1, y1. So whatever you've written in the first place here, you write that again at the end, x1, y1. Okay. Now, the formula looks like this. You multiply these values on the diagonals, x1 into y2, x2 into y3, x3 into y1. So the formula looks like this. Area is given by modulus. Modulus basically will just make whatever number you input into it, it'll make it positive. So sometimes the formula will, the inside part will result in a negative number. These two vertical lines that you have on the ends, they just make that number positive. So just remember that you have to have your final answer positive because it's area cannot be negative. That's what these vertical lines are for. So what these vertical lines, what they do is, if you have modulus of -2, the result is 2. If you have modulus of -5, the result is 5. If you have modulus of 15, it's already positive, the result is 15. So whatever you have inside these two vertical lines, it's a function that makes that number positive. Okay, that's all that it's doing. Now, what does the formula look like? You multiply these numbers, x1 and y2, plus x2 and y3, plus x3, y1. Okay. And then you look at the other diagonals, x2, y1, x3, y2, x1, y3. You subtract from this x2, y1, x3, y2, and x1, y3. This is the formula for area of a triangle with any coordinates, where x1, y1, x2, y2, x3, y3, these are the coordinates of the triangle. You can just input values in this formula and you'll get the area value directly. Okay, so how do you remember this formula? You write x1, y1, x2, y2, x3, y3 like this. Then at the end, you repeat x1, y1, and then you multiply these diagonals, add them, and then you subtract these diagonals. Okay, let me just input values now. x1, y2. Okay, x1 is 2. So we're going to have 2 into y2, which is 5, plus x2, which is -2, into y3, which is 4, plus x3, which is -3, into y1, which is 3, minus x2, y1, which is -2, into 3 minus x3, which is minus 3, into y2, which is 5, minus x1, which is 2, into y3, which is 4. You evaluate this, and that's going to give you the result. So inside, I'm getting 10 minus 8 minus 9 plus 6 plus 15 minus 8. What does that result in? Can somebody tell me what this is? I think it's 8.
There's
Is it
6.
6? Is it 6? What's this
Yes,
number?
sir, it's 6. It's 6.
6. Okay. So it's 6. So it's modulus of 6. It's already positive. If this number was negative, you would make it positive. In this case, it's already positive. So you say 6 is the answer. 6 is the area of this triangle. Okay, I'm sorry. This is not correct. This is not correct. This is not correct. I missed something here. I was just thinking this would never result in a decimal answer if we write it like this. If we have all the coordinates integers, basically, we have 1 over 2 outside. I missed that. There should have been 1 over 2 outside. So we have 1 over 2, 1 over 2, 1 over 2. And it becomes 1 over 2 multiplied by 6. And the area should be 3 instead, not 6. Okay, and that will make more sense. This area, yeah. So that's the formula. We have a 1 over 2 multiplying outside as well. I missed that. So we have 1 over 2 into this whole thing. So with that formula, you have 1 over 2 outside, 1 over 2 into 6. The result turns out to be 3 from this. That's the area using this formula. You can try this on the previous examples as well now. You would see that you would end up getting the same result using this formula as well. Any questions on this? Any question on this formula?
No, sir.
Any question on? No? Now, the good thing about this formula is it can actually be extrapolated to any figure, any shape, as long as any polygon, basically. So you could have any quadrilateral, any pentagon, any hexagon. As long as you know the coordinates of all the vertices, you can use this formula. For example, if I had a random figure like this. Now this is a parallelogram, but let me just make it slightly more random. If we had a figure like this, if we have the coordinates of these vertices given, we could find the area of this triangle like this. We write all the vertices like this: x1, y1, then x2, y2, x3, y3, but then we have x4, y4 as well. So we have x4, y4. And then at the end, we have x1, y1. And in this case as well, we multiply these diagonals. Oh, yeah, I'm sorry, I again missed the 1 over 2. We have 1 over 2 outside. We have 1 over 2 outside this as well. x1, y1, x2, y2, x3, y3, x4, y4, x1, y1. And again, we do the same thing. We multiply these and add them together. And then we multiply these and subtract them. Okay, so you can make this formula like this for a quadrilateral as well. The only condition is these coordinates have to be written in order. As in, if this is A, and this is B, then this is C, and this is D, and then we have A again. So either in this order or in this order. Not like this, that you have A, and then you have C, and then you have D, and then you have B. That would not make sense. So you have to go in one direction, right? You can start from anywhere. You can start from C as well if you want. as long as you're going one full circle like this. So whichever point you are starting from, you should be ending at that point at the end, going one full round like this. Okay, so you can do this for a quadrilateral, a pentagon, hexagon, whatever you want. As long as you know the coordinates, you can write down the area like this. Okay, but generally you don't need to do that in A levels, but that is something that you could do if you wanted. Make sense? Any problem with this? Any questions, anyone? No? Mostly, you can simplify things by using this idea that we discussed before, that the base would either be horizontal or vertical, and you can just use that and find the perpendicular height like that. Now, one last thing very quickly before we end, because I want to finish this area thing today. So just 3-4 more minutes. Area of a rhombus, or in general, area of a kite. How do you find that? Sometimes you have to find these areas. Now, if you have the coordinates, you could use that same idea that we just discussed. Otherwise, let me just show this to you. If you have a kite like this, okay. So if you have a kite like this, how would you find the area of this kite? Let's call this A, B, C, D. How do you find the area of this kite? You can break it down into two triangles, right? You can say you have this triangle, and so you have these two triangles. How do you find the area of these two triangles? You can find the area of one of them. You can find the area of this triangle, for instance. This is the perpendicular. Now remember, in a kite, this point M is the midpoint of BD. So if you had to find the area of this kite, you could think of it like this. You could say it's the area of one of these two triangles. Or write it like that first. 2 into area of one of these two triangles. Let's say area of triangle ABC, right? You can find the area of one of these two triangles and just multiply that by 2. So I'm finding the area of this triangle, this one triangle, and just multiplying that by 2. Now, how do you find the area of this triangle? Half into base into height, we can do that, right? So that will be 2 into area of ABC, that's half into base. We can take AC as the base, into height, which is MB, right? What does that give us? 2 and 2 it cancels, and we have AC into MB, right? Now, what is AC? AC is one of the two diagonals. AC is one of the two diagonals that you have in this kite. And what is BM? MB is half of one of these two diagonals. We can write MB as BD over 2. Can I do that? MB is just half of BD. And then this can be written as half into AC into BD. Now, what are AC and BD? AC and BD are basically the two diagonals of this kite. So we can write the area of a kite like this. It's half into D1 into D2, where D1 and D2 are the diagonals of this kite. Okay, so that's a general formula that we have for area of a kite. You could use area of triangle as well. You could find the area of triangle and just multiply that by 2 or if you wanted to do it directly, this is the way to do it. Area of a kite and also a rhombus, because rhombus is just a specific kind of kite, right? Because it's just a kite that has all sides equal. So it works for rhombus as well. If you want to find the area of a kite or a rhombus, it's given by half into d1 into d2, where d1 and d2 are the two diagonals of the shape. Okay, so this happens a lot, that they ask you to find the area of a kite or a rhombus. You can just use this formula directly. If you remember this makes things quicker sometimes. If you don't, then you have the backup. Just break that kite or rhombus down into two equal figures, two equal triangles, and then you find the area of one triangle, multiply that by two. That will also work. But this is the direct formula that you could use. Any problem with this? Any questions, anyone? Make sense?
Sir,
Yes.
sir, by diagonal you mean midpoint?
No, diagonal is this length. BD, this is the diagonal. AC, this is the diagonal. Diagonal is the line that joins opposite vertices in a quadrilateral. So if you have this rectangle, one diagonal is this, the other diagonal is this. In a kite, these are the two diagonals. The lines joining the opposite vertices.
Sir, it means we need to find distance BD for diagonal.
Yes, yeah, of course. We're talking about distances. Distance D1 and distance D2. Distance of AC and distance BD. So whenever we have something like this written, this means distance. AC means distance AC. MB means distance MB. Okay.
Okay, sir.
So that's the area of kite formula. It helps sometimes to make things quicker. You may have to use this as well. In the next class, we'll be doing the last concept of this topic, which is the angle between two lines, in addition to any remaining questions that you have from the worksheet. All right. Anything that you want to ask before we end today? I'm sorry, it's been a long class today. Any problems, anyone? Any questions?
No, sir.
No? Okay, that's it then. I'll see you again tomorrow. Tomorrow will most likely be the last session on coordinate geometry, inshallah. Okay, Allah Hafiz everyone. I'm just discussing this one question with Naima. If anyone wants to stay back for that, you're welcome to stay back on trigonometry. But the class is ended. If you want to leave, you're free to leave. Okay, so you're saying, Naima, that your answer is not matching with the marking scheme, but you understand how to approach it, right? So can I just show you the solution, how it would look like? It will save time. Let me see if I can find that somewhere. It was question number 5. Okay. Okay, so part B basically asks you to show that the angle CAD is tan inverse of 2 over under root 3 CA and D. Okay. So you want to find this whole angle basically, right? Now for this, what I've done here is I've used this complete length, right? This is 4D here. And then this horizontal length, this complete length, and then used tan for that, okay? Now, let me show you the working. Let me know where exactly you're confused here. So what I'm doing is, this is AX, and then this is AD on the diagram. And then vertical side was already there, 4D, just using tan with that. So let me know your exact question from this. Maybe it can help if you share with me your working so I can see where exactly you're doing you're going wrong. Okay, so you understand it right now? Okay, so what I've done is I've just copied this solution to the notebook as well. The notebook for P1 trigonometry. So you can find that here there as well now. If anyone else wants to have a look at this question again. So I've posted this, I've added the solution to this question in that notebook, P1 trigonometry. All right, so that's it then. I'll see you again. Okay, all right, that's okay. So, yeah. Okay, great. I'll see you again in the next class then. Allah Hafiz.
Allah Hafiz, sir.
Allah Hafiz. No problem. Allah Hafiz.